Hello there. For this video, I'm going to be going over the pre-flight and engine start procedure. But before I do that, I'm going to go over a little bit of the things that I'm not going to do. So in the pre-flight procedure, I'm not going to go over some of the things that in real life where flight attendants would be doing some things, and I would be, doing the pre-flight inspection around the aircraft where you're basically going around the aircraft, making sure the pitot tubes are uncovered and checking the leading edge and trailing edge of the wing. Basically just doing the pre-flight to make sure your airplane's in good condition before you get on to starting the plane. Obviously, I won't be doing that because I physically cannot in the simulator. For example, there's no way to uncover the pitos here, and there's no way to, obviously in the simulator, there's never dents on the wing. So the pre-flight will be limited to getting the aircraft powered on and all the systems ready for flight, if that makes sense. So despite that disclaimer, we'll go ahead and get started. So we'll go ahead and set ourselves in the cockpit here. All right, so we're going to start by giving the aircraft some power. So one of the ways we can do that is either starting the auxiliary power unit, which is a small jet engine in the tail of the aircraft, or we can get a ground power unit, which is what we're going to do. So we're going to turn on the ground power unit here, and we're going to start with the pre-flight procedures here. So the first thing we are going to do is we're going to go to the upper panel here. We're going to turn on the battery. Going to lock the battery switch in its position, and we're going to turn on the external power left and right bus. Okay, so now we have power to the aircraft. So first thing we're going to do is we are going to start by, one second here, let me find my viewpoint, there we go, by turning on both cross pneumatic bleed valves. And what these do is the aircraft has what's called a bleed air system. And the bleed air system is basically a series of ducts in the aircraft. And these ducts have go all the length of the airplane, and it's how it air conditions it. So the APU and the engines can provide what's called bleed air from the compressor stage, which can then be controlled by the PACs or air conditioning units, and then they're used to regulate the temperature and the pressurization of the airplane. So in order for the ducts to be opened, we need to open both these cross feed valves to allow air to bleed through the ducting system. All right, next thing we're going to do is turn on the auto brake to rejected takeoff mode. So what this will do is that if the aircraft needs to abort a takeoff, and it obviously has to slow down with the remaining length of the runway, it'll apply braking when the engines or throttles are retarded or brought down, and then or when the reverser is activated, the engine reversers are activated, the auto brake will engage and start gradually slowing down the airplane. And the reversers are basically the very gray portion on the back of the engine exhaust folds out, and it redirects the thrust of the engine from backward to forward. All right, now we'll go ahead and turn on the transponder, which is basically the way the airplane reports to air traffic control the position of the airplane, the altitude and speed of the airplane. It also gives off an identifier code, which you can see right here, so they know what aircraft you are. So we're going to set that to altitude reporting off, which means that it will tell ATC where we are, but it won't give them information such as altitude, etc., because we're on the ground. So next thing we're going to do is we're going to test the pressurization system. So we're going to set it to manual by pushing the switch. We're going to move this dial, and then we're going to turn it back to automatic by hitting this switch. And this should start to roll back. And if it does, like it is, pretty good indication that it's operating properly. Next thing we're going to do is we're going to turn on the fuel crossfeed valve. And what that does is it allows the left engine and the right engine to feed from the left wing and right wing fuel tanks if you have the crossfeed on. Next thing we're going to do is we're going to arm the spoilers. And The spoilers are these little flaps on top of the wing here, which I'll show you later, that will fold up to slow the aircraft down, and not only slow the aircraft down, but reduce the amount of lift the wing has. And the reason why we armed it is because if we need to do a rejected takeoff, we need to slow down as quickly as possible. And the way you do that is by full brake, full reverse thrust, and pulling out the spoilers. So it's armed in case we do a rejected takeoff. All right, the next thing we're going to do is we're going to set the trim setting. Now what trim is this the horizontal stabilizer, this piece right here, is what gives you the vertical control of the airplane, allows you to pitch up and down. Now, in order for the pilot to not have to continually hold back pressure on the control column here, or have to apply forward pressure all the time, you can change the position of the stabilizer to make the aircraft want to naturally fly at the current speed it's going. And the way that we do that is we calculate the center of gravity of the airplane, or where the center of the weight is on the airplane. So it could be forward or aft, and you can calculate that with this iPad over here. I can go to weight and balance, and I can put in how many passengers in the A and B section of the aircraft, how much forward and aft cargo, and how much fuel, and it will calculate the weight and balance of the aircraft and give you your center of gravity percentage. So for us, it's 13, so we're going to set it to 13. And the flap setting, which are, you can see them, they're kind of down. It's these things right here, these pieces of the wing that fold down. They increase the amount of lift and drag that the aircraft has, so this allows to take off quicker. So we're taking off with flaps 11, which is the normal takeoff flap for the MD-80. And then what we're going to do is, you see this green indicator tells you where the stabilizer trim should be, and this white indicator is where it currently is. So we're going to move the stabilizer trim, and you should be able to see the stabilizer back here slowly rotating, just like that. And now that it's in line with the green tab, our trim is set to the proper position according to our weight and balance. All right, now that that's operating, we're going to turn on the hydraulics, which are what make the controls for the pilot easier to operate. The hydraulic system also is what powers the landing gear, so it can move up and down. It also powers the flaps and spoilers, and also leading edge slats, which is basically the front of the wing here can slide down and forward to increase the lift factor of the wing. So we're going to turn on the auxiliary pump, which is an electrically powered hydraulic pump to pressurize the hydraulic system. And then we're going to turn on the transition pump, which allows the auxiliary hydraulic pump to pressurize the hydraulic system that the engines otherwise would. You can see why that would be useful in an emergency. Next thing we're going to do is we're going to test the brake temperature right here. And brake test is complete. We're also going to test what's called the traffic collision avoidance system, which basically tells the pilots whether or not there is an aircraft above or below them that is within close proximity, and tells the pilots whether they need to climb to avoid the collision or if they need to descend to avoid the collision. All right, so it just said TCAS system test OK. So TCAS system is working. Next thing we're going to test is the engine fire warning system. All right, so as you can see, it said fire left engine and fire right engine, so it's working. Next thing we're going to do is we're going to set the engine thrust mode to takeoff. So what this does, as you can see, this little orange blip here on the engines. Basically what it's saying is that it's telling the aircraft engine computer this is the max amount of engine RPM or power that we will allow it to do. So there's the takeoff setting, the climb setting, cruise setting, go around setting, MCT, max continuous thrust, and takeoff flex setting. All right, so we're obviously setting a takeoff because we're doing the pre-flight of the airplane in real life. We'd be preparing to take off. So we'll set this as the TO mode. Next, what we're going to do is we are going to uncage the secondary artificial horizon. So what we do is we pull this, let it level out, pull it again, let it level out. There we go. All right, next thing we're going to do is we're going to turn on the flight directors for the captain and first officer. Now what the flight director is these these two magenta lines, one vertical, one horizontal. And what they do is when the autopilot is functioning, or when there's a flight plan put in, these magenta lines will tell the pilot how to fly the aircraft, basically what attitude, how much bank angle the aircraft should be at in order to follow the flight plan, or what angle of attack to fly at in order to achieve the altitude you have set. Speaking of which, we're going to be setting the cruising altitude for today's flight, which is 18,000 feet. We're also going to go ahead and set the position light to both. Wing nacelle on. Floodlights can go ahead and come on. Anti-collision only comes on. The anti-collision light, which is a red beacon light, will only come on when we're preparing to start engines. And the reason for that is that the beacon light is one of the ways that you alert the ground crew that you're starting an engine, and you don't obviously want anybody or any equipment in front of the engine during a start, because it will suck it up. And other ways that you communicate is you can open the window, you can alert the ground crew, or via the communication radios here, you can talk to ground and tell them what you need. All right, next thing we're going to do is we're going to go to the upper panel here and do the pre-flight for the upper panel. So we're going to turn on the windshield anti-fog and anti-ice. So the anti-fog, obviously, as it says, will keep the windows on the aircraft from fogging up, which is important, obviously, because you need to be able to see. On the anti-ice, when you're flying through clouds in the atmosphere, and it's cold enough and the right pressure conditions are there, the windows will start to accumulate water, and that water will freeze on the windshield. And you don't want that, because then that also will reduce your visibility and also the aerodynamic quality of the aircraft, which is not as much of a big deal when the icing is on the nose, but when you have wing icing, it's very bad. You can completely lose lift on the wing and reduce the performance of your airplane. So now that those are on, we're going to turn on the pitot heat. All right. So a pitot is a tube which has air, which basically gives you the airspeed reading of the aircraft. So it's a little tube on the side of the nose here, and that little tube, which you can see there, it's on the bottom right side of the nose here, will take the oncoming air that is coming at the aircraft as you're accelerating, and the pressure of that air is correlated to the speed of the airplane, the airspeed of the airplane, that is. And so you don't want them to ice up, because if they ice up, then you have no speed reading, and also no altitude reading. So in order to prevent that, you need to turn on the pitot heat right here, which electrically heats the pitot tubes and pitot statics. So now that that's on, we can check and make sure that this dial right here shows that all of them are getting heated, which it appears they are. Next thing we're going to do is we're going to turn on the no smoking and seatbelt signs for our passengers. Let them need to be seated down. Next thing we're going to do is we're going to arm the emergency lights. Now, what these do in the event of an emergency, these lights on the ground and these exit signs will light up, alerting the passengers of the direction of exit. So that way, when the aircraft needs to be evacuated, the passengers can see if it's dark or if they're confused. Lights like that can even be good in broad daylight. So the next thing we're going to do is we're going to set the engine ignition to both. What these are is the engines have what are called igniters, which is what initially ignites the fuel inside the engine to get it running. And so we need those on preemptively, because we're going to be starting the engine soon. Next thing we're going to do is we're going to test the we're going to make sure the left and right generator are on. Sorry, I'm getting ahead of myself here, so I kind of like jump around, which is why I say I'm going to do one thing and then I say, wait a minute, gotta do this next, Anyway, so the engine generator switches are both on, left and right. We're then going to check the battery voltage and amperage, which is 50 amps, 25 volts. Everything appears to be good. Next, we're going to test the cockpit voice recorder. So this will, as the name implies, record the conversation in the cockpit. The reason for this is if there is an emergency or something happens, either a crash or a crash landing, and the pilots have either died or are incapacitated at the time that a crash investigation is going on. They can use the recorder and listen to what the pilots were talking about in the aircraft so they can get an idea of maybe what led up to the crash. Next thing we're going to go do is go farther up the upper panel here. We're going to make sure the engine fire detectors are on both for all three. The reason why you want to make sure they're on both is that there are two fire detection elements in the engines and in the APU, or the auxiliary power unit. And you want to make sure that you have it set to both, so that way if one of them is not operating, the other one will take its place. Next thing we're going to do is we're going to test the fire cargo protection system. Test here. Looks like it's operating. All the lights have enunciated. Next thing we're going to do is make sure none of the breakers are pulled out. You want all of these to be pushed in, because otherwise you will lose power to something on the aircraft. It's very important. We're also going to check and make sure the oxygen level is up. So this oxygen dial is for in the event of a cabin pressure loss at altitude. To allow the passengers and the pilots to breathe, there are these oxygen containers in the aircraft which will deliver oxygen either through the masks that drop down in the cabin, or in the pilot's case, excuse me, in these masks right here that you put on. All right, so the oxygen level's good. All that's done. We are now going to go ahead and test some other warning systems on the aircraft. So we're going to turn the logo light first of all, and we're now going to test the overspeed warning. All right, so the overspeed warning basically lets the pilots know the aircraft's going too fast, and this could possibly, it can cause flutter on the wings, which can cause the aircraft to quite literally tear itself apart, which is obviously very bad. So now we've done that, we're going to do the stall test. Okay, system 1 tested. System 2. System 2 tested. All right, so the stall system essentially lets the pilots know when the wing is no longer generating any lift, so the wing essentially isn't working, which means the aircraft's going to drop out of the sky. And that can be for many reasons. Maybe you don't have enough speed. Maybe the aircraft angle of attack is too high. Maybe a maneuver was performed too quickly. For example, the aircraft was banked too fast. It was pitched too fast. And a lot of these different things can lead to a stall. There's other things too, such as icing on the wing, which reduces the lift of the wing. So many different reasons, but I won't go into the technicality of that because it's a lot of information. Next, what we're going to do is we're going to test the anti-skid system, which shows left inboard, right inboard, left outboard, right inboard. All is working. The anti-skid system, basically what it does is when the aircraft is on the ground, if the wheel begins to slide and it's not rolling as the aircraft is moving, it will reduce the amount of braking on the wheel in order to increase the grip of the wheel, basically. So if the aircraft is moving forward at 100 knots, and the wheel was not rotating at the speed it should be rotating when the aircraft is on a ground roll of 100 knots, it will reduce the amount of braking to hopefully increase the grip of the wheel, so that way the aircraft doesn't begin sliding around. All right, next thing we're going to test is the ICE FOD test. All right, so that's all working. Left, and right systems tested. So FOD stands for foreign object debris. Now, foreign object debris can be things such as gravel, it could be ice, any number of things. And you want to be able to tell if there is FOD on the wing of the aircraft or on the cowling of the aircraft, in order to prevent the engine from ingesting these particulates, which can cause the engine to stall out and die, basically. So it's very important to test that. All right, next thing we're going to do is we're going to turn on the PACs, or air conditioning units. So the air conditioning units are called PACs, and what they do is they have two jobs, actually. As I mentioned just a second ago, they maintain a temperature in the cabin and cockpit, but not only do they maintain a temperature in cabin and cockpit, they're also responsible for pressurizing the cabin, because obviously at 30,000 feet, you won't be able to breathe. So what it does is it maintains a cabin altitude of anywhere from 1,000 feet to 10,000 feet, which is a breathable range. All right, so now that the packs are on, we're going to now set the pressurization system. The pressurization system uses the packs and regulates the rate of cabin climb, so how quickly the cabin altitude is increasing. So right now you can see it says standby on and transfer lockout. So we don't want to be on the standby pressurization system. We want it to be on the primary. So you set it to primary and then you click the button to stop the transfer lockout. The transfer lockout, the reason why it's there is if for some reason in flight this switch is hit, you don't want it to switch the pressurization system mid-flight unless it's necessary. So what it does is it locks out. So even though I moved it to standby back to primary, it stayed on primary the whole time, unless I were to push the transfer lockout. Next thing we're going to do is we're going to set the cabin altitude, or cabin landing altitude. So basically what this means is the airport that we're going to be landing at, which is Kilo Oscar November Papa, and this airport has a certain elevation above sea level, just like any airport. And you want the aircraft to depressurize itself to the pressure of the altitude it's landing at, right? And that's about 200 feet. So we'll set it to a landing altitude of 200 feet above sea level. This right here is the landing barometer. So a barometer setting is done here on the altimeter, and the barometer needs to be set to a certain level in order to make sure that the altimeter is reading your actual height above sea level. So right now the barometer setting is 3013 inches in mercury, which means that we are 1,333 feet above sea level, which is, as you can see, the altimeter is reading that just about right. The reason why you have to change the altimeter setting is that things such as the temperature of the air, which changes the pressure of the air, can change the altitude readout. And in order to make sure that it is accurately reading out your altitude, you need to calibrate it to basically what the current temperature and pressure settings, is currently. And in order to do that, you turn this dial right here, this sparrow. So we have it set to 3013, which is in mercury, or 1020 millibar. So the next thing that we are going to do, because we can't set the barometer because we don't know what the barometer setting is in Newport right now, we leave that untouched until we get there. So the next thing we're going to do is we're also going to turn on the fuel pumps for the tanks that have fuel in them currently. You don't want a fuel pump on for a tank that doesn't have fuel in it, obviously. So that's set. Now that we are done with the initial pre-flight, I think, let me just, is there anything? Oh, one more thing. And we have to test the passenger address system. Okay, it's going to test the attendant calling light. There we go. So that's tested now. All right. We're also going to turn on the galley power here. Now that the entire plane is essentially set up, besides the flight plan, which I'm going to be going over how to set a flight plan in the next video, what we're going to do now is we're going to start the APU. So the way that we do that is we turn on the start pump, which pressurizes the fuel system that goes to the APU to make sure the APU has adequate fuel pressure to start. Next thing we're going to do is we're going to set the APU master switch to start, and we're going to wait for an RPM percent of just under 10. It's about 8. And once it jumps up to 8, then we set the master switch to the run position right now. So now we're going to wait for the APU to spool up to its maximum percent RPM, so 100. And we're also going to watch the EGT, or the exhaust gas temperature, climb, make sure it doesn't go into the red. And so now we just wait for that. All right, the APU is now running, and you can see this blue light just came on, telling us that APU power is available. So we no longer have to run off the ground power unit. We can just go ahead and turn on the APU left and right bus, and turn off the GPU buses, and we can go ahead and remove the ground power unit, since it's no longer necessary. We can also remove the iPad here, because we don't need that. All right, now that we are on APU power, we need to wait about 1 minute, because the APU goes through a 1-minute cycle before it allows bleed air to come out of the APU. If you remember when we talked about bleed air, you'll know what that means. So we'll go ahead and turn on the APU air conditioning switch on, which allows bleed air from the APU to pressurize the packs, the air conditioning units, and also the pressurization duct. In just a little bit here, we will see the air conditioning units get pressurized. Well, there we go. Just above 2 psi, which is normal. And you can also see that there is some pressure here on the pneumatic pressure valve for the engine start. All right, now that the APU is running, we can get on to the last part of this video, which is the engine start. So for the engine start, we need to make sure the start pump is on, because the engine also uses that. We're going to set the engine ignition to both, which we already did, if you remember. And we're then going to turn off the packs, because they're taking all that precious duct pressure that we need. And as you can see, the pack pressure goes to 0, and the ducting pressure goes up to just above 4 psi, and that's the minimum that we need for engine start. You have to make sure you have at least above 4 psi. All right, so next thing we do is we open the guard that goes over the left engine start switch, and we're going to go ahead and start the left engine. So we're going to pull the switch down, and you'll see it says start valve, and you're also going to notice that the engine N2 percentage is rising. Now, N2 is one of the stages of the compressor of the engine, because the way a jet engine works is that it takes in air, compresses it to high pressures, introduces fuel, which that high pressure air with the fuel ignites, and then that gets blasted out of the back of the engine, which makes thrust. All right, so now that the pressure in the N2 stage is 23, we can go ahead and introduce fuel. And you can kind of hear it. The engine is slowly starting up there. And we're going to wait for the engine to stabilize. We're going to go to the external view, and we can go ahead and listen to it. Do not worry, the engine is spinning. It's just that these initial blades in front of the main intake blade in the back are called stators. And they don't move. Only the ones behind it move. All right, so as you can hear, the engine is running. And now we're going to wait for the engine to stabilize here. Make sure it engine's stable, and then we can go on to the next engine start. I would also like to point out some of the things I'm leaving out because they're just tedious, and I only do it when I'm doing full flights, is you would check all the systems on the aircraft. You would check each of the engine dials here to make sure the engine's performing properly. You check hydraulic pressure, oil quantity, oil temp, etc., and make sure that all of these are optimal before takeoff. The only reason I'm not doing it is for time's sake. I have done the research into this, just takes a lot of time. I don't want the video to go on for more than an hour. All right, so now that that engine is stable, we can go ahead and move the engine start switch to off, close the guard, and now we can start the right engine. So we're going to open the right engine guard, set the starter switch to on. It says right start valve open, and the engine will be spooling up. So we're going to wait for the N2 percentage to get to 20%. All right, 20%, and we can introduce fuel into the engine. Now, the right engine is starting. You can hear it spooling up there. Perfect. Now wait for that engine to stabilize. Just give it a second. All right, the engine is stable, and the aircraft has switched the power to the engine, so we can turn off the APU power bus. And, in fact, we can go ahead and turn the APU off since the engine is now powering and applying the bleed air to the aircraft. So we can set that to off. We can turn the packs to on. And now the engines are pressurizing the pack system and air conditioning. There we go. And now the APU goes through another 1-minute cycle, so we turn off. We're going to set the APU air conditioning switch to off. And that is the entire aircraft started. Everything's done, and you can see we have no annunciations besides the parking brake is on and the rudder travel is unrestricted, which is completely normal for this stage. So that is the entire pre-flight for the MD-80. Of course, I am not doing a pre-flight that exactly correlates with the airline, because each airline has its own procedures that are slightly different. And so I'm just doing the general, what needs to be turned on to make sure the entire aircraft is running. And we did all of the major tests that need to be done for the aircraft systems, besides the takeoff config test, which is where you move the throttles forward. And then once the throttles have been moved forward, it gives you a warning telling you whether or not you have your flaps down, or if the parking brake is still engaged when you're trying to take off. So other than that, that is the entire startup for the McDonnell Douglas MD-82. And I'm going to go ahead and end the video here before it gets any longer. And I hope you enjoyed. Farewell.